In this video, we're going to take a look at the collection interface, which was at the top of this chart. The collection interface is up here. So let's talk a little bit about the collection interface. Okay, so the collection interface is the root interface for manipulating a collection of objects. If you look here, we can see all of the public methods that are defined in the collection interface. So if something's going to be part of the collection, it has to have an add method. It has to have an add all method. It needs to have a clear method. It has to have a contains or a contains all method, an is empty method, remove all, a retain all, a size, a to array method, and a stream. That's a lot of things to write if we want to do that. Now, the abstract collection, if we go back to the chart here, abstract collection implements a lot of those things for us. So that these concrete classes that we're getting to down here don't have to write those. So the abstract collection writes everything, I believe, except the add method, I think the size method, and that might be, and the iterator methods. So the abstract collection writes all of these for us, provides all of them, except for those three that I just mentioned. And you can see what these methods do. If we want to add an item to the collection, we can use the add method. Whatever the concrete class is has to implement the add method. So as we've seen in array list, there's an add method to add an item to our array list. So collection defines all those things. The abstract collection actually implements most of them, and then the concrete classes will implement the rest. You can also see that the collection interface has this iterable interface combined with it, and we'll talk about that here in a second. And iterator basically says that we have to have a way that we can traverse the collection. So we've seen that with for each loops. Let's take a look at the iterable. So an iterator is a classic design pattern for walking through a data structure, examining each element of a data structure without having to expose the details of how the data is actually stored in the data structure. So it has methods for us to look at the next item in the list or the previous item in the list, or similar things like that. Java 8 added the for each method to the iterable interface. So for each kind of makes this using an iterator a little bit easier. And we're going to look at some examples of that. So here is an example of a collection, which is, in this case, is a collection of strings. It's an array list. Okay, and we add some items to it. We add New York and Atlanta and Dallas and Madison to that list. Then we create this iterator object by calling collection, which was the name of our collection, .iterator. It creates an iterator, and then we can say while iterator has a next item, we're going to print out. So this basically will step through each item in our collection, and in this case, it's switching it to uppercase and printing it out. That's quite a bit of code to just do a simple loop, basically, of printing things out. And that's kind of the old way to do it. You don't see too many people doing it that way anymore. So here's the easier way. We have this collection and we add our 4 items to it, and then we can say collection.forEach, and for each element in the collection, there's an E there. We're going to system.out.print, whatever that element is converted to uppercase. This single line does the exact same thing as what we saw in this example. It took 1, 2, 3, 4, 5 lines of code. All right, so this is using an iterator, and this is the newer version of using the for each method that's built into the collection. In the next videos, we're going to actually take a look at the list interface.